like a couple minutes, maybe a minute. You can wear them if you want. Hello, folks! We are live here with Mark from Piper. That's playpiper.com, is that right?
Yeah.
So what is it?
So Piper is a computer kit that kids build and program themselves for the game Minecraft. We think of it as the first computer that kids build and actually use themselves.
It does kind of have a Minecraft aesthetic. Can we look at it?
Sure, definitely. So this is how the kit comes. It's
so cool.
Minecraft style, and got kind of Minecraft aesthetic on the back. And so once kids actually build this computer, they learn programming electronics through the game of Minecraft.
Cool.
When you open it up, you can actually see that the gears on the outside spin.
That is so cool.
And part of this is we wanted to teach kids through these kinds of experiences, through these kind of curious, wonderful experiences. They open the box and they think, how does this actually work? And you realize, oh, it's just a visual illusion.
It's such magic.
Then inside the kit, you have a welcome letter. Welcomes you to the adventure, and you're on a mission to save Earth.
So who is Lieutenant Tommy? Is that your robot mascot?
That's actually one of our teammates. And
oh, cool!
Yeah, he does all our customer support.
Neat. There's this amazing blueprint thingy. Maybe we'll look at that after we go through this.
A full life-size blueprint. Yeah, that's how you assemble it.
Wow, that's so cool.
And then you have all the components and parts you need to assemble your own fully working computer. You got the screen, all the wooden components, the mouse.
Look at this laser cutting. It's so nice. And there's like acrylic bits too, as well as plywood. It smells amazing.
One interesting thing is we found that most kids, they've never actually used a screwdriver in their life.
Really?
So we include a screwdriver in here.
Cool.
And for a lot of kids, who kind of grow up doing iPads and playing online games, building something real is a novelty.
This is so cool. So what are all the little letters in the back of here for?
Oh, so those you actually put on the outside.
Oh, cool.
Once you've, right here, you actually insert them into the
Oh, nice.
Holes.
Cool, and you got a mouse, you've got a bedboard.
There's a little speaker under there.
Oh, cool.
You open that up.
Oh, wow, yeah. Magic. How did you choose the name?
Oh, so
It reminds me of the Pied Piper from...
Oh, I've never heard that before.
Oh, no.
No, I'm kidding.
Oh, okay. We have a troll here.
We were thinking of, we wanted something with the Raspberry Pi. We were thinking Pi or something. Right. And then initially we're actually teaching kids coding, web coding, and we're thinking about, programming and coding. They're kind of like, the internet in general is kind of like a series of pipes. And kind of like the pipes in our buildings, they are really important for us to live in our buildings, but we don't actually really know how that stuff works. The same applies to the internet. So we were thinking, maybe Piper is the experience that gets you to understand how the internet works and how technology works.
Cool.
How connections work, yeah.
It almost has a little Mario connection, too, of like being plumbers for the internet. A little battery.
Exactly. So that's the kit disassembled.
We're going to give you another video on Monday of it actually being like the whole thing. Like, okay, I'm going to show you a sneak peek. But like this. Ooh, is how it ends up looking. It's got these sweet hinges and this like metal hardware. It's really aesthetically pleasing. And oh, I see. These little like plastic blocks and stuff that go in here. That's so rad. Alright, so let's have a look at this blueprint then.
Yeah, here it is.
In the while we're unfolding this, so how did you end up making Piper? Your background is as a biologist, right?
Right, yeah.
What's the story?
Yeah, I was actually, it's kind of a long story, but I was, doing a project in Ghana. I was teaching kids about global health.
Wow.
Through gaming. So I designed this curriculum to teach kids about malaria and infectious disease. Yep, that's the blueprint.
Wow. This is totally massive. I would have loved to have this on my wall when I was a kid. Like, wow.
Yeah, so a lot of kids, they actually, spread this out on the floor, dump out all the pieces, and then just kind of go at it.
Oh, yeah, totally.
Kids as young as 7, assemble. It takes about anywhere from 1 hour to 2 hours. So 7 through 12 is kind of the standard age.
Wow. And
kids learn, everything from mechanical engineering to electrical engineering, computer science after they've assembled it.
And like you aim it at kids, but my sibling is 32 and is really into Minecraft and also wants to like do Raspberry Pi stuff. So I don't know, maybe a Christmas present. It's $299, right?
Right.
But you can get a 10% off discount using the code Hackster if you go right now. So that info is also in the description to this video. So check it out. So you were in Ghana. You were teaching kids about through gaming.
Yeah. So I designed this curriculum to teach kids about malaria, infectious disease,
wow.
by playing games, and it was going really well. But then I got sick myself and almost died. Had to be evacuated.
Wow.
And that made me realize that if I want to make an impact, I should do it in a more scalable way.
Huh.
So I started teaching myself programming, and then I realized it's just like a language. You know, earlier you were learning Spanish, right? You're trying to teach yourself lots of different languages. The earlier you start, the easier it is.
Yeah, totally.
And so I thought, man, I really wish I had something when I was a kid to get me started with this stuff, to make it more natural so I can become more fluent.
Yeah.
And I was thinking, what did I like? I like playing video games. I liked Legos when I was a kid. I thought, how do you combine those two? So there's physical, hands-on building, but also some kind of digital engaging experience on the screen. Because kids today, they're really addicted to iPads, to mobile games. And we thought, it's hard to get them off the screen, but how do we augment that screen experience so you also get some, tangible, physical, hands-on?
Yeah.
And so actually, when you play the game, we'll show this for the users later. But you actually, as you play, you actually continue to build. So as you play on the screen, you're building your controller, you're building lights and switches. Cool. So the game actually walks you through how to continue building the electronic components as you're playing.
That's super legit. I had a comment, but I've totally forgotten it right now. It had to do with Minecraft. Because Minecraft. So is it the game that you are designing is not Minecraft? It's a different one.
So we use a version of Minecraft that's on the Raspberry Pi.
Cool.
It's called the Raspberry Pi version of Minecraft. It comes on every single Raspberry Pi, and there's an API for it. So we actually just use the API and just design all our levels and experiences through that.
Super cool, because one of the first projects we had on Hackster was someone building, I think it's called Redstone, is that the conductive stuff? They were building little things to interact with that and make switches in the game that you would turn stuff on and off in real life. It's so cool that this is becoming more of a thing. It's super exciting. Well, thanks. Is there anything else you want to add, like maybe upcoming announcements or other things before we do our magical cut thing where we're going to come back on Monday and show you about how to actually put this thing together and the sort of boot up experience?
Well, we're going to have some new releases, some new products coming out in the fall, so stay tuned for that. And and we're right now actually going to a lot of schools as well.
Cool.
So lots of schools, I think over 1,000 schools at this point use Piper to teach kids about electronics, engineering, and computer science. So if you have schools or you'd like to get us into your school, please reach out.
Sweet. Is there any geographical constraint there, or?
No, just in the United States.
Nice.
Yeah.
Cool. You could be having this experience I'm having right now, except in a classroom. You go to teach the people?
We have folks who do that. Yeah.
Okay, cool. Maybe not Mark, but somebody equally cool. Thanks for coming by.
Awesome. Thanks, Alex.
Thanks for watching. Have an awesome rest of your Wednesday.